All right, imagine this. There's a shape that goes on forever, stretching infinitely far. But somehow, it has a limited amount of space inside. Now, here's the weird part. If you wanted to paint the outside, you'd need an infinite amount of paint. This is Gabriel's horn, a mind-bending paradox where infinity doesn't behave the way you'd expect. Consider the function f of x equals 1 over x. Now, take the region under this curve from x equals 1 to x equals infinity and rotate it around the x-axis. The result is a three-dimensional shape that extends infinitely in one direction. This is Gabriel's horn. Now, let's find its volume using the volume integral. So, the volume of the Gabriel horn is pi times the integral from 1 to infinity of 1 over x squared. Notice how 1 over x squared is simply x to the power negative 2. Thus, we use the reverse power rule, which gives us negative 1 over x. Now, just use the fundamental theorem of calculus. Substituting in the bounds gives us the volume as pi. Now, let's find the volume of Gabriel's horn using the surface area integral. So, the surface area of the Gabriel horn is 2 pi times the integral from 1 to infinity of 1 over x times square root of 1 plus the derivative of 1 over x whole squared. This integral seems a bit weird, so notice how the squared derivative term always increases the value of the integral. We can use an inequality here and get that the surface area of the Gabriel horn is greater than 2 pi times the integral from 1 to infinity of 1 over x. The antiderivative of 1 over x is natural log x. Using the fundamental theorem of calculus and substituting in the bounds, we get the area greater than 2 pi natural log of infinity minus natural log of 1, which is basically infinity, since natural log infinity approaches infinity, and that natural log of 1 is just 0, making no difference. So, the area of the Gabriel horn is infinity. How is this possible? Let me know what you think in the comments.